This is ShiJie from China University. Our paper's title is Simultaneous Detection and Tracking with Motion Modeling for Multiple Object Tracking. Our first contribution comes a deep learning network that can simultaneously estimate multiple object motion parameters, visibility, and classes in an end-to-end manner. As our second major contribution, we propose a realistic large-scale dataset with accurate and extensive ground truth annotations. Currently, most deep learning-based MOD methods rely on off-the-shelf detectors, which result in detector bias. Moreover, they are often divided into interdependent subtasks, including detection, feature modeling, similarity estimation, association, and even prediction. To some extent, it reduces the robustness of the MOD tasks. The detection task is to locate objects in an image space. Similarly to this, MOD task is to locate objects in time image space. Essentially, detection and tracking should be a same task. The trajectory of an object in a video clip can be described using time-dependent equation, as shown in the following figure. You can see that we can use the motion parameters to locate the object in the time image space. In addition to motion parameters, the classes of each object and the visibility at each frame should be required. To this end, we introduce deep motion modeling network that can estimate multiple objects' motion parameters, visibility, and classes in an end-to-end manner simultaneously. This network contains 4 subnets. The first subnet is a feature extractor. It can receive multiple video frames to extract the 3D feature map and send these 3D feature maps to other 3 subnets. The second subnet is the motion subnet. It can estimate the motion parameters of all the anchor tubes. The third subnet is the classifier subnet. It can estimate all the anchor tubes classes. The last subnet is the visibility subnet. It can estimate the visibility of all the anchor tubes. Based on the architecture, the overall loss of the diamond net is defined as a weighted sum of the 3 sub-losses, including the motion loss, the clarification loss, and the visibility loss. In the test phase, the trained diamond net is deployed in the tracking framework. For 32 frames, the trained diamond net selects 16 frames as its input and outputs predicted tubes encoded by object motion parameters, classes, and visibilities. These outputs are then filtered, and the track type is updated by associating the filtered track light by via IOU with the previous track light. We also contribute a large-scale public dataset, OmniMOD, for vehicle tracking. It is generated with color simulator. Here is a demo video of this dataset. We also released the source code for generating the OmniMOD dataset. This is the easy camera viewpoint in the clear visor. This is the easy camera viewpoint in the cloudy visor. This is the easy camera viewpoint in the right visor. This is the middle camera viewpoint in the clear visor. This is the middle camera viewpoint in the cloudy visor. This is the middle camera viewpoint in the randomizer. This is the hard camera viewpoint in the clear visor. This is the hard camera viewpoint in the cloudy visor. This is the hard camera viewpoint in the randomizer. We evaluate our technique using the proposed omni-MOD design. We also evaluate our techniques using the UAD track design, which is better performance and reaches more than 120 frames per second. You can find more details in our paper and all project pages. Here are the demo videos of deep motion modeling result in the UAD track design and omni-MOD design. You can see that in the demo video of omni-MOD site, there is a tree and the network can well deal with the totally occlusion cases. Okay, thank you for your listening.